Question number 7. Figure 3 shows the design for a structure used to support a roof. The structure consists of 4 wooden beams AB, BD, BC and AD. Given AB is equal to 6.5 meters, BC is equal to BD, which is equal to 4.7 meters, and angle BAC is equal to 35 degrees. Find to one decimal place the size of angle ACB. So, the first thing we need to do here is to find the size of angle ACB, which is this one. Alright, so let us look inside the triangle where the angle is contained. What is the information given to us? So we are given this angle 35 degrees and we are given the side opposite to this angle. Next, we are asked to find this angle and we are given the length of the side opposite to it. This clearly indicates to us that we can use sine rule to find the missing angle. So let's write the sine rule. We have sine of angle ACB divided by the length opposite to the angle, which is 6.5, is equal to sine 35 divided by the length opposite to sine 35, which is 4.7. Therefore, sine of angle ACB is equal to 6.5 times sine 35 divided by 4.7, and therefore angle ACB is equal to sine inverse of 6.5 times sine 35 divided by 4.7. We calculate this using the calculator. We press shift and sine, so we get sine inverse, and then we enter the value which is given in the bracket. And we get the value angle ACB is equal to 52.5 degrees. So this is the answer we have got for the required angle here. Alright, but if we look at the figure and observe carefully, the angle is an obtuse angle. So this angle is clearly obtuse, and here the value that we have got by the calculation is the value for an acute angle. So you should be familiar with the formula. Sine theta is equal to sine 180 minus theta. So we have sine of 52.5, that should be equal to sine of 180 minus 52.5. Therefore, sine of 52.5 is equal to sine of 127.5. Therefore, we get the value of the obtuse angle ACB as 127.5. Okay, now you can understand this better by checking it out on a sine curve. So this is my sine curve, alright, and I have this as 180, this as 360, and this as 0. So this is what my sine curve looks like. Alright, now let us take any angle theta here. So if I am taking theta here, the value of sine theta can be obtained by looking at the y-axis here. Alright, now I go to 180 and I look at 180 minus theta, which is this angle. So I first want to win it 180 and then I came back minus theta. So the value of this angle also is the same on the y-axis. That's why we realize that sine theta is the same as sine of 180 minus theta, and hence we have the above answer. Alright, that answers to the part 1 of the question. Question 7b. Find to the nearest meter the total length of the wood required to make the structure. We have almost all the lengths here except the length AC and the length CD. Alright, let us look at the triangle that contains the length AC. It's the triangle ACB. Alright, now in this triangle, we need to find this length and we are given the angle opposite to it. Alright, also we are given this length and the angle opposite to it. So that is clearly an indication that we can use sine rule to find the missing length. So let's write the sine rule for finding the length AC. So we have AC divided by sine 17.5 is equal to 4.7 divided by sine 35. Therefore, AC is equal to sine 17.5 times 4.7 divided by sine 35. Calculating on the calculator, we get the length AC is equal to 2.464 meters. Alright, now moving on to the other missing length, which is CD. Alright, so we look at this triangle CDB. We need to find the length CD and we are given the angle opposite to it. Alright, also we are given this side and we are given the angle opposite to it. Again, this is a clear indication that we can use sine rule to find the missing length. Alright, so let's write the sine rule to find the missing length. So we have CD divided by sine 75 is equal to 4.7 divided by sine 52.5. Therefore, CD is equal to sine 75 times 4.7 divided by sine 52.5, and calculating on the calculator, we find CD is equal to 5.722 meters. Now all we need to do is to find the total length. So total length is equal to sum of all the sides. The sides are AC plus CD plus DB plus BA plus CB, and the corresponding lengths are 2.464 plus 5.722 plus 4.7 plus 6.5 plus 4.7. Adding all, we get 24.086 meters. Now we need to give the answer to the nearest meter. Alright, so our answer is 24 meters. Alright. Question number 8. The curve C with equation y is equal to f of x is shown in figure 4. The curve C has a single turning point, a maximum at 4, 9. So this is the single turning point, which is a maximum. It crosses the coordinate axis only in two places, which is negative 3, 0 and 0, 6. So the curve crosses the y-axis at this point and it crosses the x-axis at this point. and it has a single asymptote with equation y is equal to 4. So the dotted line that you can see is the asymptote with the equation y is equal to 4. So part A of the question says, state the equation of the asymptote to the curve with equation y is equal to f of negative x. So f of minus x is in fact a transformation where every x coordinate becomes negative and the y coordinate remains unchanged. So we need to see if the curve has this transformation, what happens to the asymptote. Alright, so let's bring in this image. Now if we see here, we have the graph of f of minus x and the asymptote remains unchanged. So the red curve that you can see is the graph of f of minus x, and we see that the asymptote remains unchanged. So the answer to part A will be x is equal to y is equal to 4, because the equation of the asymptote remains unchanged. As we can see, it's the same line that extends through. Alright, moving on to part B. State the coordinates of the turning point on the curve with equation y is equal to f of 1 by 4x. So this is a transformation where every x coordinate is divided by 1 by 4. Alright, we can see the coefficient of x is 1 by 4, which means every x coordinate on the curve is divided by 1 by 4. Now we need to see that with this transformation, what happens to the coordinate of the turning point. Alright, so let's see. The x coordinate of the turning point is 4. If it is divided by 1 upon 4, this is in fact 4 into 4 by 1, which is 16. So the coordinates of the turning point, the x coordinate will be 16 and the y coordinate will remain unchanged. Okay, moving on. Given that the line with equation y is equal to k, where k is a constant, intersects C at exactly one point, state the possible values of k. So there is a line y is equal to k that intersects the curve. Now we should know that whenever the equation of a line is in the form of y is equal to k, it's always parallel to the x-axis. So we have lines that are parallel to the x-axis which cross the curve at one point only, and we need to see which are those lines. So the first line that we can see that crosses the curve only at a single point can be this one, which passes through the point 49. Alright, so the equation of this line will be k is equal to 9. Alright, so the value of y is equal to k, where value of k is equal to 9. Alright, so let's see if we have more lines that cross the curve only at a single point. Now if we have a line passing through somewhere here, we see that it crosses the curve at 2 points. Alright, if we move further down, it still crosses the curve at these 2 points. And if we move further down, alright, here it will cross the curve only one time, and further down from this point as well, the lines, all of these lines will cross the curve only at one point. So any line which has the value of k less than 4 will cross the curve at a single point only. Alright, moving on to the next part. The curve C is transformed to the new curve that passes through the origin. 1. Given that the new curve has the equation y is equal to f of x minus a, state the value of the constant a. Now we should know that this is a transformation which pulls the curve vertically down. or it just slides the curve down. So now we need to slide our curve in such a way that it passes through the origin. So we need to focus on this point, because this is the point that can slide and come down to the origin, because this is a transformation which pulls the curve down as it is. So if we need to bring this point down, by how much does it move? It moves 6 steps towards the lower side, or towards the lower part of the y-axis. As we already have a minus here, which indicates we are coming towards the lower side, so the number of steps are 6. So our equation is y is equal to f of x minus 6. So the value of a that we are looking for is 6. Alright, moving on to the last part. Write down an equation for another single transformation of C that also passes through the origin. Now we need to write another single transformation that also passes through the origin. So the other option that we can see is if this whole curve slides to the right side. Alright, so it's going to be like this, somewhat like this. So it's a movement towards the right hand side. Alright, so how do we write the transformation? The transformation is y is equal to f of x minus a certain value. Now this value is the number of steps that we are moving to the right, and we are moving, when we move from this point to this point, we are moving 3 steps to the right. So our answer is y is equal to f of x minus 3 in bracket. Alright.